Welcome. On this video, we're going to concentrate on the directrix and the focus of a parabola. So let's get started. But before we go into detail, let's just review some ideas that we have discussed previously. So we have discussed that there are four different directions that a parabola can take, either facing up, down, left, or right. And here we're just going to review two of those four. So if my parabola it's facing upwards, there's two things that we know. The first one is the way that the standard form is going to look like. Well, since it's facing in a vertical manner, either up and down, so I know that my x value is positive, but my x value is the one that is being raised to the second exponent, sorry. And since it is facing upwards, then I know that my focal distance will have a positive value. Now, h and k will always represent the vertex. And notice that here we're defining the focus to be h, comma, k plus p. So what does this mean? Well, since p represents the focal distance, and h and k are the location of the vertex, and p is the distance from the vertex to the focus, but notice that this point right here is going to be the previous location, but not just move upwards p values or p units. So therefore, we can define the focus as just the h doesn't change because we're not moving it either left or right, but notice that we're moving it in a vertical manner, so it's going to be k plus this distance that we define as p. K plus p. This is how we can define the location of the focus if we know the value of our vertex and the actual value of the focal distance. In the other direction, since this is a parabola, we state that any point should be equidistant in terms of its focus and its directrix. So if the distance between the vertex and the focus is of a value of p, then also the distance from the vertex to the directrix should be of a value of p as well. So how can we define the value of this directrix? Well, the way that we're defining this directrix is k minus p, which k comes from the y value of the vertex. So if we slide it p units down, then we can definitely define this y value as just h minus p. I'm sorry, k minus p. Another thing, that's what happens if we're looking at a parabola that is facing either up and down. That's how we can think about the focus. Remember, there's a relationship between the vertex, the focus, and the directrix. The vertex, it's part of a parabola, and the distance from the vertex to the focus, it's equivalent to the distance from the vertex to the directrix, based on the definition that we have for parabola. And the same idea can be applied if our parabola is facing either left or right. Now the difference is that since my parabola it's facing horizontally, meaning it is facing either left or right, my standard form is going to change a little bit. Y is the value that is being raised to the second. And at least in this very specific example, since it is facing to the right-hand side, then I know that my p value it's positive. And the same idea applies here. Because now, if I know that my vertex is being defined as h comma k here, and the distance between the vertex to the focus is being defined by this value of p, which we define as a focal distance. So therefore, the exact location of this focus is going to be h comma h plus p comma k. So what does this mean? Well, this means that I start at the value of h and I move p units to the right. So my new location of this focus is h plus p. And k doesn't change because we're not moving the focus either vertically, neither up and down. It's all a horizontal distance. So therefore, we're only moving it to the right. So we can only have to add the p value to the vertex, the x value on my vertex. And now the directrix can be defined exactly the same way that we have done it here, because I know that directrix, it's equidistant to the vertex as the vertex it is to the focus. So if the distance from the vertex to the focus is p, then therefore the distance from the vertex to the directrix should be of a p as well. But since I'm moving it to the left-hand side, I'm subtracting a value of p. So therefore, I can define my directrix as just being h minus p. Because remember that h we're locating here. And if I move p units to the left, I'm going to be hitting the directrix. So therefore, my directrix can be defined as x equals h minus p. And now that we have done that quick review, let's jump into some examples now. Let's apply what we have been discussing so far. So let's state the coordinates of the vertex and the coordinates of the focus given this parabola. But notice that it seems that x, is the one that is being raised to the second exponent. So based on our previous conversations, we can see that my parabola is going to be facing either up or down. But now notice that the value in front of the parentheses with the y on it, it's positive. So we can see that the p-value is actually a positive. How can we see that? Well, recall, since we already know that my parabola it's facing upwards, since the x is the one that has been raised to second exponent, then I know that its standard form will have the form of x minus h squared equals 4p y minus k. Since this is the equation that we have previously, if we want to start analyzing, notice that this 8, we need to write it in terms of multiples of 4, because that's how we can define the value of p. So notice that if we rewrite this given equation in terms of 4, 8 can be seen as 4 times 2. And now it will be easier for us to see that the p-value of the focal distance has a value of 2. And also, since this is x minus h, then we can see that my h value, it's of a value of 3, and the k is going to have a value of 5. And at this point, that's all we need, because now we can say, look, the focal distance is a p-value, which we already saw it as being a positive 2. And now the vertex, which again, we're always going to define as h comma k. In this case, my h is 3 and my k is 5. So we have answered this question, which now, what is the location of the vertex? Well, the location of the vertex is 3 comma 5. And can we define the location of the focus? Well, I guess we have not answered that one yet, but we can definitely answer it with the information that we have now. Because now, if we draw a small picture of what's going on here, I have, and again, this is going to be a rough draft, I have a vertex whose location it's at 3 comma 5. So let's just say that this is 3 comma 5. Now, what do I know about this parabola? I know that this parabola has a positive p-value and the x is 2 seconds, so therefore I should be opening upwards. So where is my location of the vertex? I'm sorry, the focus. Well, the focus, I know that it's going to be somewhere in here, since it's always going to be inside the parabola. But what is the exact location? Well, I know that the focal distance, it's a value of 2. And I know that it should be going on a vertical matter going upwards. So therefore, my vertex can be seen as just this location plus 2 units. So let's just say that that's about here. So therefore, my focus now, well, let me just write it here on the side. My focus now is going to be 3 plus 5 plus those 2 units. So therefore, I can see that my focus has a value or has a location of 3 comma 7. And notice that all we're doing is we're just applying what we have discussed in our previous class based on what we know about parabolas. So let's just do 2 quick examples here. So let's start by looking at example number 1. Now let's just do it as a class. Well, first, let's use the parabola given on the introduction to find the following. But what parabola are we discussing? Well, we're discussing this parabola. We're discussing the parabola of x minus 3 squared equals 8, y minus 5. And let's find the following. Well, what is the value of the focal point? Well, the focal point we already defined. We saw that the focal point has a value of 2, since if we get our 8 and we write it in multiples of 4, I know that the value that needs to be multiplied is 2, so therefore my p-value has a value of 2. Now, what is the equation of the axis of symmetry? So what do we mean by that? Well, let's start by writing a more precise graph instead of just saying it is a sketch. So here we have a better graph, so a little bit more of a precise graph now. And now, what is the equation of the axis of symmetry? Well, the axis of symmetry, it's a line that will cut our parabola in such a way that if we fold it along that line, my parabola is going to overlap with another section of the parabola. But now, another way of looking at the axis of symmetry, at least when it comes to parabola, the axis of symmetry, it's also a line that passes through my focus and my vertex. This will always be true. The axis of symmetry, at least when it comes to a parabola, it's a line that's always going to pass through the focus and the focus and the vertex, which now, how can we define this line? Well, notice that this line can be defined as x equals 3. And now, notice that this fits the definition of an axis of symmetry, because if we get this parabola, if we get this section and we fold it along this line, notice that this section of the parabola is going to overlap with this section of the parabola. So that fits the description of an axis of symmetry. And a key property is that the axis of symmetry always passes by the focus and the vertex. Now, how can we define the equation of the directrix? Well, what is the directrix? Well, the directrix, let me just do it in red here. Let me just choose the red. Okay. So here we have our parabola, and I know that the focus is 2 units away from the vertex. So therefore, my directrix should also be 2 units away from my vertex, but in an opposite direction. Because here's my vertex, my focus is 2 units up, so therefore my directrix should be 2 units down. And now, how can we define this red line? Well, that can be defined as shows y equals 3. Now, what is the the x-intercepts of this parabola? Well, notice that this is my vertex, and it's always going to be facing upwards. So does my parabola ever touch the x-axis? It will never touch the x-axis, because we know that it's a parabola, and it's always going to be facing upwards, so there's no way that my parabola will ever touch the x-axis. So therefore, there is no x-intercepts. So we have answer A, B, C, and D. And now, can we sketch the graph? Well, little by little, we have sketched our graph. We notice that here we have a parabola that is facing upwards, whose vertex is at the location 3, 5, whose focus is at the location 3, 7, and it has a directrix at the value y equals 3, and an axis of symmetry of x equals 3. So now for our next example now, we're going to be doing a more algebraic manipulation, because now notice, well, let's read it. It says, let's state the coordinates of the vertex, the coordinates of the focus, the equation of the axis of symmetry, and the equation of the directrix of the parabola, given this equation. And this should start looking a little bit different compared to what we have been discussing so far. Because if we take a look at the way that this equation is being defined, this equation looks nothing like any of the standard forms that we have discussed previously. Once your equation is written in standard form, then it's easy for us to identify the vertex and the focal distance. But it's not that easy to see where the vertex is in this equation, or where or what is the focal distance. So how can we get that information given this type of equation where the equation seems to be just to be a polynomial? So how do we do that? Well, the first thing to recognize is this. Notice that we only have one variable that is raised to the second exponent, which in this case, it's the y. So y is being raised to the second exponent. So if y is being raised to the second exponent, then perhaps my equation should look something like this. Because in this case, x should not have a second exponent. Y is the one that has a second exponent. So therefore, I need to be able to rewrite the whole expression, that this whole polynomial, into this form, because that just kind of fits my first observation. But how do we accomplish that? Well, for that, we're going to be using completing the square. So how do I know that I need to use complete the square? Because notice how this expression is being written. Here we have a binomial raised to the second exponent, which is the result of an expression that is being completed the square on. So let's do that. Let's complete the square, but we're going to be completing the square on the y variable, since the y is the raised to the second. So therefore, I need to complete the square on the y, because I need just to make it look something like this. So let's do that. How do we complete the square in terms of y? Well, the first thing that we have to do is, let's just isolate those terms that have a y on it. So let me move 8x to the left. That way this cancels out. And let me move 25 to the right. So that cancels out. So now I have my new equation to look something like y squared plus 6y. That's equivalent to minus 8x minus 25. So now that I have this, let's actually complete the square now. So since I'm completing the square on the y, I'm going to take a look at what's in front of the value of y. So I'm going to get that value. I'm going to divide it by 2, which is 3. And I'm going to raise this value to the second, which is 9. Now that I have this, if we want to complete the square, we want to come back to our equation, and we're going to be adding 9 on both sides. So my new equation is going to look something like this, plus 9 equals 8x minus 25 plus 9. All right, great. Because now that we have this, I can complete the square on the left-hand side, which notice that y squared plus 6y plus 9, that's equivalent to just y plus 3 all to the second. And on the right-hand side, let me try to combine this 3 terms. So I have negative 8x minus 25 plus 9, that's equivalent to minus 16. All right, so it's starting to look something like what we wanted. But the first thing that I noticed is that I should have been written in terms of y minus k. But here I have y plus 3. So therefore, perhaps it would be wise for us to just write it as y minus 3. So notice that all I have done is, instead of writing as a plus, I'm going to write minus minus. That way still it's a plus, but now it will be easier for us to identify that the k value is going to be a value of negative 3. So now at least I know what the k value is, which is negative 3. But now the right-hand side, it just doesn't look what we wanted it. But I can see one thing. If I take a look at both terms that I do have here, notice that I can factor out a negative 8. Because if I factor out a negative 8, I'm going to end up with x plus 2. Now notice that it's starting to look like that. Notice that it's starting to look like that. So if we continue with this, I'm going to have y minus 3, parentheses. But now notice that negative 8, if I wanted to write it in terms of its standard form, I can write it out as 4 times Let me just screen in this case, times -4. I'm sorry, -2. Look at that. Definitely, -8 is 4 times -2, but I need to write it in terms of a 4 because that's just how we write down our standard form. And now this parenthesis x plus 2, I need to make it look like x minus h. So therefore, I can see, and let me just do that in blue now. This plus 2, I can write it as -2. And now by doing that, it will be easier for us to identify what the values of k is, p is, and h is. Because now I can see that k has a value of -3. I can see that p has a value of -2. And I can see that h has a value of -2. And that's all we need to define this parabola. Because now notice that I can start seeing, okay, so what do we know about this equation? Well, I can see that my vertex, again, my vertex, it's always defined as h comma k, which in this case, h is -2 and k is -3. So now I know the value of my vertex. So let's place that here. So I know that my vertex is -2 comma 1, 2, 3. Oh, sorry, 1, 2, 1, 2, 3. So here I have my vertex, which let me just use a little b on it. Now, what's the value of my focus? Well, let's see. If this is the standard form, notice that y is being raised to the second. So therefore, I have a parabola that is facing either left or right. But I notice that p has a negative value. So therefore, my parabola should be opening some direction to the left-hand side. So therefore, my focus should be somewhere in here. But how do we define the exact location? Well, remember that the focus is going to be the vertex plus or minus the focal distance. But I know that the focal distance has a value of -2. So therefore, my focus, let me do it in purple here. The focus should be the vertex and 2 units to the left. So 1, 2. So here we have our focus. And how do I know that it's 2 units away from the vertex? Because that's the value that we got for the focal distance. So now I know that my focus has a value of -4 comma -3. Now for our axis of symmetry, let's do that in green. For the axis of symmetry, well, we say that the axis of symmetry, at least when it comes to parabola, it is a line that passes through the focus and the vertex, which in this case, I can see that my axis of symmetry is going to look something like this. But what is the definition of that line? Well, that line can be seen as y equals -3. And the last thing that we need to define is the actual directrix, which let's do it here in this light blue. So where are we? Directrix. Well, the directrix is, we're going to use the same idea as we did to define the focus, but now the directrix is going to be on the opposite direction of the focus. So if I'm moving 2 units to the left, I define the focus, then from the vertex, 2 units to the right, oops, let me just make this a little bit more straight. 2 units to the right is how we should be defining our directrix. Oops, well, imagine that's a straight line. So here we have our directrix. And what's the value that we have for that directrix? Well, this directrix, it is a line whose value is x equals to 0. So now this is well, I'm not going to say it's an exact interpretation of a parabola because we don't know how open or how narrow my parabola should be opening, but at least a good interpretation of what this parabola should look like, where we have our direction, we have our focus, we have our line of symmetry or our axis of symmetry, and we have our directrix. And with this, we have concluded our lesson for the directrix and focus of a parabola.